So today we're talking about the business case for shifting live-to-VOD media processing to the edge with just-in-time transcoding, right? So lots of acronyms in there. Live-to-VOD meaning if you've got a pay TV subscription service, eventually, even if you're a broadcaster or a niche events provider, you've got live feeds coming in that people want to catch up with later. It's a 24/7 kind of situation, not a burst kind of situation. You want to build that in your network, we'll see why. You want to do it with a just-in-time transcoding paradigm, we'll see why. And at any point of time, please feel free to interrupt me with questions. We're here to convey information, not talk. So the three things I'm going to tell you. First of all, you want to build out live-to-VOD media processing in your network. There are different ways to do it. It's still going to be in the cloud, but it doesn't necessarily work if you do it as a SaaS or a PaaS. You want to build it into your network in a virtualized environment. We're going to talk about why the economics favor just-in-time transcoding versus a just-in-time packaging approach, and we'll get into what those two different alternatives are. Essentially, you have a choice of transcoding everything, storing it, and then picking the stream you want, versus just storing one copy, transcoding it live, and sending it out on a transaction-by-transaction basis. Used to be you could only do JIT-P. The world's changed. You can do JIT-T now. And because of a number of other factors we'll look at, in the long term, that's going to be your better bet from an economic perspective. Under our modeling scenarios right now, and we'll talk about the parameters, we'll talk about their trends. Are they going to move up? Are they going to go down? What are the risk factors associated? Right now, the total cost of ownership of JIT-P, which is the way you're doing things right now, is going to come out about twice as much as JIT-T, which is what new technology is enabling if you look at a 5-year model. So let's see. Why would you want to build live-to-VOD at the edge? Okay, so is live-to-VOD a familiar term for everyone? You've heard of it? You know what it means? Okay, live-to-VOD is essentially time-shifted multi-screen. Okay, so every time you are recording a show on your PVR, watching it on your tablet, every time you're logging into Xfinity or some other similar service and catching up online, it could be on an Xbox, it could be on your own DVR, that's live-to-VOD. So you're going from a broadcast situation to a unicast situation. And that, it's also called start over TV sometimes, pause and rewind TV. Whenever you go from broadcast to unicast, that's a live-to-VOD. The live-to-VOD video traffic is going to more than double just this year. It's going to continue to double year over year after that. What you're also seeing is right now you have about 1 in 4 pay TV households consuming TV everywhere. You're going to see that grow to 1 in 2. Now, being that pay TV households in North America are about steady, that means you're going to have double the number of subscribers and about 8x amount of video between now and 2017. You need to gear up to meet that demand. If you don't, there's another service provider waiting to take those subscribers in. For that infrastructure, you'll have heard from many places that the cloud makes sense. It does, but the cloud isn't one thing. Okay? If you're doing burst events, so the Olympics, the World Cup soccer, a presidential campaign, when your traffic spikes up and goes right back down, you're not going to build that infrastructure in-house. You're going to actually SaaS it out. If it's going to be 24/7, you want to build that into your network. In the network, at the edge of the network, but in your network. It's still going to be software defined. It's still going to be software based, but it's going to be in your network, on premises. So you want to seriously consider, definitely if you're an operator, honestly also if you're an OVP or if you're a current SaaS provider. Because if you look at the way that your video is projected to grow, FFmpeg on Amazon is great, but it's not going to scale over time. So you want to start to build out now to meet the projections moving forward. Otherwise, again, there's a competitor just in line behind you. Are there any questions so far? All good? Okay. So this is what we mean by JIT-T versus JIT-P, and this is an important distinction. So JIT-P is the way it used to be done. You'd have a stream come in, you'd do all your ABR profile transcodes. Typically, you'd have 1.2 megabits per second as the mezzanine coming in. You'd go down all the way down to 320, sometimes 160. And then depending on a specific connection, you switch a given stream in or out. Easy stuff. As you can see, that requires a lot of storage. So you don't have as much load on your transcoder because you have some flexibility in how many transcoders you can throw at the problem and how long it takes to transcode. But you're going to need a lot of storage to keep all the recordings at all the bit rates there. With just-in-time transcoding, which is a bit of a misnomer because you have to just-in-time transcode as well as just-in-time package. So it's actually JITTP, but at some point it's just unpronounceable. So JIT is where you just store the highest possible resolution, typically, and then as you start a transaction, you transcode it, encrypt it, package it, send it out. Why is that an important distinction? Used to be you couldn't transcode at this kind of rate. Once upon a time, you actually would need to transcode it offline, and you'd be challenged just to package it at the volumes that were coming up. Now we have a new set of chipset technologies. We've got a new set of servers. There's acceleration that's built in. JIT is cost-effective, power-effective, and feasible. That's why we're having this discussion in the first place. Any questions? Okay. So, yeah.
Well, in the case of JIT, what are you typically looking at in terms of the sources for that? Are you just speaking in the context of live, strictly live, and not also VOD?
So it's live to VOD in that your incoming stream is live, and then you're converting that to VOD. So how quickly you can make the VOD available depends on how effective your infrastructure is. With some broadcasters and operators, you'll see it takes them 6 hours or a day to get certain shows up live. With others, it'll be immediate. And I think BBC has a really interesting case study. Just give me your business card after the talk, and I can forward it to you. They went through a range of architectural options to figure out how to minimize the latency from the live to the VOD. And so that's an architectural decision in and of itself. All right, so when we started modeling the costs of JIT-T versus JIT-P, right, we had the hypothesis that JIT-T should come out to be cheaper in the long run versus JIT-P, essentially because any infrastructure is a combination of two components. There's the storage component, which is extremely expensive, and then there's the transcoding component, which can have a wide range of pricing. And so we wanted to go back and see, okay, how much are you recording? How much are you actually using? What are you transcoding? What are you storing? And how can we put all that data together in a model that's realistic? And then what do the costs look like? So we have an average of 2.5 hours per household that's being recorded today in the cloud, and that we expect is going to rise over time as more people are recording individually and as operators allow you to store more and more data in a recording. Is everyone familiar with the you must keep 1 copy of content per subscriber rule in the cloud? Everyone's okay with that? Okay, with cloud DVR, under current US copyright in the US jurisdiction under current copyright law interpretation, you're required to keep 1 copy of content per subscriber who has requested you to record a program. So there are some jurisdictions where you can just store 1 copy for all your subscribers. In the US, you're required to store 1 copy per subscriber. That changes your storage dynamics quite a bit, okay? So under this assumption, we're doing this entire model. If you only had to store 1 copy per user, everything would change. The mezzanine bitrate we're assuming is 1.2 megabits per second. I have it trending flat. In theory, you could say, compression's going to get better, maybe it should trend lower. Or you could say 4K is coming, maybe it should trend higher. Let's keep our life simple. It's steady for now. An interesting finding we saw was you only usually watch about 1/4 of the content you record. And that's going to have huge implications on the transcoding loads that we're going to see and the corresponding capacity you have to build out. This number is actually falling. The more you record, the rate at which you're recording is increasing much faster than the rate at which you're viewing. And so the percentage of content you view as compared to the percentage of content you record is falling. In the JIT-P infrastructure, you end up storing about 3x the amount of input data. Because remember, you're storing the mezzanine, and then you're storing all the bit rates underneath it. So it's kind of a pyramid, works out to 3x. That's going to have implications in the infrastructure you have to roll out up front and in the maintenance costs moving forward. We'll see that. The other thing you're going to see is the JIT transcoder is actually 10 to slightly more expensive than a JIT-P transcoder because of the load you're going to put on it. But because you're only transcoding 1/4 of the volume that you would, and that 1/4 is directly correlated to the 25% that you're viewing, That's, again, fourth in terms of input. If you count output volume, it's actually 1/12, but we'll keep it simple, 4x. Put those two together, and this is what you get. So in JIT-T, you're spending, again, a third on storage. You're spending a lot more on transcoding, but the sum is still lower. And then on an ongoing basis, you see that because your storage is lower and because the transcoder is actually more efficient in and of itself, and you're only transcoding a small fraction, the ongoing OpEx is considerably lower as well. Any questions on how we translated one to the other? Any BS sniff tests? Everyone believes what I'm saying?
One other question.
Yeah.
So one of the numbers that you use for the source is 1.2 megabits.
Mhm.
I assume you're only targeting mobile phones. So it's not a view where you may also be targeting, connected TVs or consoles, as an example.
That's fair. What we've seen is usually for OTT transport, 1.2 megabits per second is the consensus mezzanine rate. You're right that some will send higher bit rates, and actually the higher the bit rate, the more the economics work in favor of JIT versus JIT-P. And so we just decided to choose sort of the least common denominator. Most people will tell you that they use the 1.2 megabits per second as the highest profile for their OTT. But you're right that there are cases where they'll go as high as 3 or 4. And then once, of course, you get to 4K, then it's off the charts. But the higher the number, the stronger the argument in favor of JIT-T versus JIT-P.
You're talking about per subscriber need to have a copy, and I guess it's a lot of redundant data because people are watching the same program.
Yes.
Why can't it be just just chopping that into a 1 second of second and just record the index like a starting point, ending point instead of just.
So the reason isn't technical. The reason is illegal. It's because of copyright law. And I agree, if engineers ran the world, we'd just run it so much better. Please tell me there are no lawyers in the room where I'm going to get hounded on the way. But no, it's because of the legal copyright restrictions. The way that the content licensing works, you're required to have 1 copy per user. There's no technological reason whatsoever. Yeah, I agree. It doesn't make sense.
Sorry, can I just clarify something from my understanding? Are we talking about origin-only architecture here, or are we talking about transcoding and packaging in the deep edge at the edges of the distribution network, or is this all pre-caching?
This would be, I believe, pre-caching.
And at the edge, mostly at the edge networks, right? We're talking
Yeah.
about deep edge.
But the operators may have their own caching and edge delivery optimization. It doesn't necessarily have to be a third-party edge or CDN. It could be, but this is the core infrastructure that it would mirror what's in the head end. It's not the broadcast infrastructure that's going to the set-top boxes, but it would typically be correlated to the head end. Okay, but we can talk offline. Any other questions?
Just talking about the relative storage versus encoding costs. I don't know if that's on the next slide.
I think it should be. So, yeah, here. All right, so again, when you look at the relative TCO, so I took the very optimistic approach of an 8% interest rate. I mean, granted, it's about 2% now, but 8% makes the numbers look worse in favor of JIT-T, so it's the conservative approach. The TCO comes out to be very strongly in favor of JIT-T. Again, it's half the TCO. And where are those savings coming from? So even though the transcoder is more expensive, the storage is considerably higher. So if you look at the CapEx here, you're using 1/3 the amount of storage. And it's the storage that accounts for the vast majority of expenditure, regardless of what model you choose. So you want to minimize the amount of storage as things stand today, as opposed to trying to cut down on transcoders, just because the percentage of cost is lower. Also, over time, there's always the possibility that there will be a disruptive fall in the price of storage. It's far more likely that there will be a disruptive fall in the cost of transcoding, because in storage, you're already kind of hitting the boundaries of what it costs to produce versus what's being sold. Whereas on the transcoding, it's, and I can see, I'm going to get flogged in a minute. I can just see that happening. because it's software centric, you have arguably a higher profit margin, and arguably you're going to end up having more competition as well. So if you had to make a bet on storage getting cheaper or transcoding getting cheaper, I would bet that transcoding is going to get cheaper. Of course, if you removed the rule of 1 copy per user, everything changes, but nothing we've seen right now in the 5 to 7 year time frame even is indicating that that is going to change. Another thing that would switch everything is if we magically decided this is the one profile and the one format in which we're going to send all content out, right? So you just have to transcode and package once and you're set. I don't think that's happening anytime soon. If anything, we're going to have more codecs, more resolutions. And so you can see that the fragmentation on the JIT-P side is just going to increase combinatorically. Versus on the JIT-T side, you store it once and then, yes, you have to transcode in many more profiles, but that's arguably a more palatable problem. Also, I've seen, so when I went out and talked to the field about, hey, JIT-T versus JIT-P, what do you guys think? Is this palatable? Would you do it this way? Would you do it that way? A lot of the pushback we got was, well, those transcoders are really expensive. And again, I'd like to emphasize the storage is really, really expensive too. And if you look at the overall model, that's the blue bar on the right graph is how much more the transcoder costs. The red bars are how much you save year over year. So yes. Yes.
What kind of storage are you modeling against?
So we looked at the storage that was being used by 4 different operators, and we averaged it across 3 different vendors. I can tell you who they were just offline, and then.
So are they proprietary? Are they software-defined storage architectures?
So how you leverage the software, how you leverage the storage is a different story. This is just the actual iron itself. So we're not counting the cost of orchestration layers on this side or that side. That tends to be negligible compared to your CapEx rollout. We're also not counting professional services fees because they tend to be comparable on both sides. Does that answer your question for now? And then I'll catch up more later. Also, I should emphasize, we took an on-premises storage approach. There are a lot of folks who are actually using storage in the cloud. So they store everything on the cloud and then they transcode in the cloud and deliver. That actually comes out to be more expensive over time. So the on-premises and the 5-year model is the cheaper version. That's what we used for our comparisons. But you can use storage on the cloud. A lot of CDNs will let you do storage on the cloud as well. And so those are our key takeaways once again. If you need to download the paper, and we go into quite a bit of analysis, this was commissioned by Vantrix. It is an objective study, so it's not a pay-to-play kind of story at all. But we look into all the different parameters. We've talked about the positive and negative risks of what we're projecting. And again, if you have any questions, don't hesitate to reach out to me or to the Vantrix team. Is there any other questions for now?
In the study on the compression side,
Mm-hmm.
were you guys specific on a particular type of codec, or did you look at the computational complexities of moving to HEVC or something beyond HEVC, larger resolution? The computational requirements on these next-gen formats, these resolutions are much, much higher than if we were to compare that today to 5 years from now. Does that still hold true?
Yes and no. So let me give you the short answer, and then let me give you the long answer until they cut my mic off. All right. So in the short term, we've looked at AVC. We've looked at AVC because over 98% of traffic going out right now is AVC. Also, if you've been following the talks I'm doing, or I'll do it again tomorrow, if you look at the ROI analysis for AVC versus HEVC, it doesn't make a whole lot of sense, even over the next 5 years, to use HEVC instead of AVC, where AVC is already working well today. So if you want to get HD out to folks who don't have adequate broadband, or if you want to get 4K out to folks, by all means use HEVC. But if you're looking at doing OTT the way you're doing it today, it actually makes far more economic sense to use AVC versus HEVC. So you're right in that if you were to theoretically say HEVC is going to cut your level of storage by half, but the transcoder is going to be that much more expensive, how are you going to handle all of that? Once you factor in the fact that 100% of your audience isn't going to be on HEVC, arguably 98% of it is going to still be AVC, you don't get that magic multiplier anymore. And if you look at the way that HEVC per channel prices are trending right now, by the time that 60% of your audience is on HEVC, the AVC encoders will have caught up in terms of cost and capacity. So one way or another, that wasn't, it wasn't, even though it was a factor we considered, it's not something that had material impact on our findings.
Although that's true, keep in mind that HEVC doesn't have to be used for the last mile. It can be used for distribution of that content and storage and then retranscoded into H.264.
In which case you're talking JIT again.
Yeah, I am talking
Yeah,
about it.
yeah.
In which case the complexity is still there, but then the argument of not using it because of 5 years of customer adoption kind of goes out the window.
Yes and no. Because you still have to have the client and you still have to have the ad support and the metrics and a lot of the other pieces in place. There are cases where using HEVC makes sense, like right this minute, but it's not in the vast majority of cases. And I may be completely wrong. I'm open to debate on this, but yeah, we can run through it today and again tomorrow. I'm more than happy to be corrected on HEVC. It's just we haven't seen that argument actually play out in terms of the numbers yet. Questions? I guess we're good. Thank you, everyone. Appreciate it.